Hello everyone, my name is P. Vaishali. Welcome back to my channel and my channel name is P. Vaishali's Mathematics Classes. We are learning a chapter from the 9th standard CBSE board, Polynomials. In previous video, we have completed 2.1 exercise. Before going to the exercise 2.2, let us learn what is the zero of a polynomial. The value at which our polynomial becomes 0 is called as the zero of that polynomial. I will take an example of this so that it can be understandable. 3x minus 2. If we put x is equals to 1, what we will get? 3 into 1 minus 2. 3 minus 2, it is the 1. Have we got 0 here by substituting x is equals to 1? No. Next case, put x is equals to 0. 3 into 0 minus 2. 0 minus 2 will get the minus 2. Next, if we put x is equals to 2 by 3, then 3 into 2 by 3 minus 2. Here 3 get cancelled. 2 minus 2 will be there. We are getting the 0 here. Means the value at which the polynomial becomes 0 is called as the 0 of this polynomial. If I ask you, what is the 0 of this polynomial? What is your answer? X is equals to 2 by 3. This is the 0 of this polynomial. And what are these? X is equals to 1, x is equals to 2. If somebody asks you, what is the value of P of 1? At that time, wherever x is there, you have to substitute the value of the 1. So this is called as the value and this is the 0. And actually, how can we get the 0 of this? For the given polynomial, first step is, if somebody asks you, find out the 0 of this polynomial. First step, 3x minus 2, you have to equate it to the 0. Means the given polynomial, you have to equate it to the 0. Then 3x is equals to minus 2. If it goes other side, then it will become plus 2. 0 plus 2 is the 2. X is equals to 2 by 3. In this way, we can get the 0 of a polynomial by equating the given polynomial to the 0. And in other words, we can also say that this is called as the 0 root of that equation. Let us start the exercise 2.2. In that question number 1 is, find the value of the polynomial 5x minus 4x square plus 3 at x is equals to 0, x is equals to minus 1 and x is equals to 2. As I told you, the given polynomial, you can take it as the P of x. First, let the P of x is equals to 5x minus 4x square plus 3. Here, what value we have to put here? 0. Put x is equals to 0. If we put x is equal to 0, then P of 0 will be. Wherever x is there, you have to substitute with the 0. 5 into 0 minus 4 into 0 square plus 3. 5 into 0 is the 0. Here is also the 0 plus 3. 0 plus 3 is the 3. Next, this is our given polynomial minus 4x square plus 3. It is the P of x. We have to substitute x is equals to minus 1. Put x is equals to minus 1. Wherever x is there, we have to substitute with the minus 1. P of minus 1 equals to 5 into minus 1 minus 4 into minus 1 whole square plus 3. 5 into minus 1 is the minus 5. Here minus 1 whole square means minus 1 into minus 1 plus 1. 1 into minus 4 is the minus 4 plus 3. Minus 5 minus 4 minus 9 plus 3. Minus 9 plus 3 is minus 6. Therefore, we will get P of minus 1 is equals to minus 6. 5x minus 4x square plus 3. This is the polynomial P of x. What we have to take here? Put x is equals to 2. Then P of 2 will be 5 into 2 minus 4 into 2 square plus 3. 5 2s are 10 minus 2 square is the 4. 4 4s are 16 plus 3. 10 plus 3 is the 13 minus 16 is the minus 3. Here you can write as therefore P of 0 is equals to 3 comma P of minus 1 equals to minus 6 and P of 2 is equals to minus 3. The question number 2 is find P of 0, P of 1 and P of 2 for each of the following polynomials. First polynomial is given as P of y is equals to y square minus y plus 1. First of all, we have to put y is equals to 0. So P of 0 is equals to 0 square minus 0 plus 1. 0 minus 0 plus 1. This is the 1. Next, put y is equals to 1. If we put y is equals to 1, then P of 1 is equals to 1 square minus 1 plus 1. 1 minus 1 plus 1. Plus 1 minus 1 get cancelled. We'll get the 1. Next, put y is equals to 2. P of 2 is equals to 2 square minus 2 plus 1. 2 square is the 4. 4 minus 2 plus 1. 4 plus 1 is 5 minus 2, which is the 3. Next, given polynomial is 2 plus t plus 2t square minus t cube. This is our given polynomial. First of all, we have to put t is equals to 0. P of 0 will be 2 plus 0 plus 2 into 0 square minus 0 cube. So all are the zeros. We will get the zeros only. 0 plus 2 is the 2. Next, put t is equals to 1. Then P of 1 is equals to 2 plus 1 plus 2 into 1 square minus 1 cube. 2 plus 1 plus 1 square is the 1. 1 into 2 is the 2 minus 1. 1 cube is the 1 only. Minus 1 plus 1 get cancelled. 2 plus 2 is 4. Next, put t is equals to 2. We have to put t is equals to 2 here. P of 2 is equals to 2 plus 2 plus 2 into 2 square minus 2 cube. P of 2 will be 2 plus 2 plus 2 into 2 square is the 4 minus 2 cube is 8. 2 plus 2 plus 2 4 is 8 minus 8 plus minus 8 and plus 8 will get cancelled. 2 plus 2 is the 4. Third bit is P of x is equals to x cube. we have to put x is equals to 0 first. P of 0, 0 cube means 0 it is. Next, put x is equals to 1. P of 1 is equals to 1 cube which is 1. Then put x is equals to 2. Then P of 2 is equals to 2 cube. 2 cube is 8. Next, fourth question. P of x is equals to x minus 1 into x plus 1. This is the given polynomial. First, to get P of 0, we have to put x is equals to 0 here. P of 0 is equals to 0 minus 1 into 0 plus 1. 0 minus 1 is the minus 1 into 0 plus 1 is the plus 1. Minus 1 into plus 1 minus 1. Next, put x is equals to 1. If we put x is equals to 1, then P of 1 we can get 1 minus 1 into 1 plus 1. 1 minus 1 is 0 into 1 plus 1 is the 2. 0 into 2 is the 0. Next, put x is equals to 2. Here, P of 2 is equals to 2 minus 1 into 2 plus 1. 2 minus 1 is 1 into 2 plus 1 is the 3. 1 into 3 is the 3. In this way, for all these polynomials, we got P of 0, P of 1 and P of 2. Question number 3 is, verify whether the following are zeros of the polynomial indicated against them. Means here the polynomial is given and against a value is given to you. Whether by putting this value we can get the 0 or not. If we get the 0, we can declare that it is the 0 of this polynomial. If we don't get the 0, then we should write as it is not the 0 of that polynomial. Let us proceed now. Given P of x is equals to 3x plus 1 and here the value is given as x is equals to minus 1 by 3. Now put x is equals to minus 1 by 3. Instead of x we have to write minus 1 by 3 here. P of minus 1 by 3 equals to 3 into minus 1 by 3 plus 1. 3 and 3 get cancelled. 3 ones are 3, 3 ones are 3. What is remain? Minus 1 plus 1. Minus 1 plus 1 will be 0. As we got the 0 here, therefore, x is equals to minus 1 by 3 is the 0 of the polynomial, that is P of x is equals to 3x plus 1. In this way, we have to write the conclusion of this. Next question. P of x is equals to 5x minus pi. Here it is given that x is equals to 4 by 5. We have to put x is equals to 4 by 5 in above equation. Here we can write here directly, put x is equals to 4 by 5 in above polynomial. So P of 4 by 5. Instead of x, what we have to write? 4 by 5. 5 into, instead of x, 4 by 5, let us substitute it, minus 5. 5, 5 get cancelled. 4 minus 5. Have we got 0 here? No. Means x is equals to 4 by 5 is not the 0 of this given polynomial. Therefore, x is equals to 4 by 5 is not the 0 of P of x is equal to 5x minus 5. In this way, we have to write the conclusion of this. Next question. Third one. P of x is equals to x square minus 1 comma x is equals to 1 comma minus 1. P of x is equals to x square minus 1. In first case, we have to put x is equals to 1. in the second case, we have to put x is equals to minus 1. We have to substitute both the values here, one after another. Put x is equals to 1. P of 1 is equals to 1 square minus 1. 1 square is the 1 minus 1. 1 minus 1 is the 0. Here we got 0 by substituting x is equals to 1. Next, put x is equals to minus 1. P of minus 1 equals to minus 1 whole square minus 1. Minus 1 whole square means this square is for the minus also. That's why minus into minus will become plus. 1 into 1 is the 1. 1 minus 1 equals to 0. Now, if we substitute 1, we got the 0. If we substitute minus 1, also we got the 0. Therefore, x is equals to 1 comma minus 1 are the zeros of P of x equals to x square minus 1. The fourth question is P of x is equals to x plus 1 into x minus 2, comma x is equals to minus 1, comma 2. Given polynomial P of x is equals to x plus 1 into x minus 2. First, put x is equals to minus 1. Now, P of minus 1 equals to, here, wherever x is there, we have to substitute minus 1 here. Minus 1 plus 1 into minus 1 minus 2. Minus 1 plus 1, the value is 0 into minus 1 minus 2 is the minus 3. 0 into minus 3 is the 0. Next, put x is equals to 2 in the given polynomial. P of 2 equals to 2 plus 1 into 2 minus 2. 2 plus 1 is 3 into 2 minus 2 is the 0. 3 into 0 is 0. For both the values, as we got the 0, that's why, therefore, x is equals to minus 1, comma 2 are the zeros of P of x is equals to x plus 1 into x minus 2. Let us solve the next question of third one. Fifth, in that fifth bit, we are going to solve P of x is equals to x square, comma, x, put x is equals to 0 in above polynomial. P of 0, 0 square, 0 into 0 is the 0 only. Therefore, x is equals to 0 is the 0 of P of x equals to x square. Here you have to write down the conclusion compulsorily, because without this we can't tell the what is the result of this. Next, P of x is equals to Lx plus m. This is given to us. Now put x is equals to minus m by L. Wherever x is there, we have to substitute with the minus m by L. P of minus m by L equals to L into, at the place of x we have to write minus m by L plus m. L get cancelled. What is remain? Minus m plus m, which is equals to 0. As we got the 0, that's why x is equal to minus m by L is the 0 of this polynomial. Therefore, x is equals to minus m by L is the 0 of P of x is equals to Lx plus m. Next question. P of x is equals to 3x square minus 1, comma, x is equals to minus 1 by root 3, comma, 2 by root 3. P of x is equals to 3x square minus 1. This polynomial is given to us. Now first case, in first case, x is equals to minus 1 by root 3, we have to substitute. Put x is equals to minus 1 by root 3 in above polynomial. P of minus 1 by root 3 is equals to 3 into minus 1 by root 3 whole square minus 1. 3 into minus 1 into minus 1, this will become the plus, divided by root 3 whole square, means root 3 and the square get cancelled. After this we will get 3 into 1 by, as square and square root get cancelled, only 3 will be remain, minus 1, 3 get cancelled, 1 minus 1 is the 0. In the next case, put x is equals to 2 by root 3. Now, let us see this is also S0 or not. Here it is declared that minus 1 by root 3 is the 0. Now let us check for the 2 by root 3. 3 into P of 2 by root 3 is equals to 3 into 2 by root 3 whole square minus 1. 3 into 2 square is the 4, divided by root 3 whole square and square root get cancelled. As we know that a by b whole square can be written as a square by b square. That's why we can separate the powers to their numerator and the denominator. I am going to write it directly here. Minus 1. 3 get cancelled. The remainder is 4 minus 1, which is equals to 3. Have we got the 0 here? No. Means we can write here. Therefore, x is equals to minus 1 by root 3 is a 0 of P of x, but x is equals to 2 by root 3 is not a 0 of given P of x. Final bit of this question number 3. Given that P of x is equals to 2x plus 1. This is given to us. Put x is equals to 1 by 2. P of 1 by 2 equals to 2 into 1 by 2 plus 1. 2 get cancelled. 1 plus 1, which is the 2. As we haven't got 0 here, we can write the conclusion. Therefore, x is equals to 1 by 2 is not a 0 of the polynomial P of x equals to 2x plus 1. Fourth question of the exercise 2.2 is find the 0 of the polynomial in each of the following cases. How we get the 0 of any polynomial? In earlier case, what we did, there x value it was given to us and we determined whether it is the 0 of the given polynomial or not. This time we have to find out the 0 of that polynomial. To solve this question, how can we solve this? First of all, the given polynomial should be equating to the 0. To get the 0 of P of x, then P of x should be equals to 0. What is the P of x? X plus 5, which is equals to 0. It is nothing but the solving the value of x only, means getting the 0 of any polynomial. which implies x is equals to minus 5, because if it go other side, then 0 minus 5 will be the minus 5. Therefore, x is equals to minus 5 is the 0 of p of x is equals to x plus 5. Next, p of x is equals to x minus 5. We have to do the same procedure for all of these questions. Now, p of x is equals to 0, because we want to get the zeros of this polynomial. Now, substitute x minus 5 equals to 0, which implies x is equals to 5. This is the 0 of 5 is a 0 of x minus 5. The third question is given as p of x is equals to 2x plus 5. To get the zeros of this, equate this p of x to the 0. P of x is 2x plus 5 equals to 0. Here we have to get the value of the x. First of all, we have to send this plus 5 to other side. 2x is equals to 0 minus 5. 2x is equals to minus 5. X equals to minus 5 by 2. Here we can write minus 5 by 2 is a 0 of 2x plus 5. Next polynomial, p of x is equals to 3x minus 2. To get the zeros, p of x should be equals to 0. P of x we can write here as 3x minus 2 equals to 0. 3x is equals to 0 plus 2 is the 2. 3x equals to 2. X is equals to 2 by 3. 2 by 3 is a 0 of the polynomial 3x minus 2. The question number 50 is given as p of x is equals to 3x. Now, p of x is equals to 0. Substitute substitute 3x instead of the p of x equal to 0. X is equals to 0 by 3, which is the 0. So we can say that 0 is a 0 of 0 is a 0 of p of x equals to 3x. Here also we will get the same type of the answer here. P of x is equals to ax, comma a is not equals to 0. Why this a is not equals to 0? I will tell you after solving this. First of all, p of x is equals to 0 we have to take. So what is p of x here? A into x, that is ax equals to 0. X is equals to 0 divided by a. Here it is given that a should not be 0. If the denominator becomes 0, we can't determine the value of this. That's why a should not be 0. X is equals to 0 by a is the 0. Therefore, x is equals to 0 is a 0 of ax. The last question of the exercise 2.2 is p of x is equals to cx plus d, comma c is not equals to 0 and c comma d are the real numbers. I will tell you the meaning of this. Let me solve this question. P of x is equals to cx plus d. So here we are finding the zeros. That's why we should equal we should equate this p of x to the 0. Then what is the p of x here? Cx plus d equals to 0. Cx is equals to 0 minus d, which is the minus d. X is equals to minus d by c. Here c should not be 0. In earlier case also we got the same type of the situation. There was 0 divided by a is not equals to 0. But here c should not be 0. So we can say that minus d by c is a 0 of the polynomial p of x is equals to cx plus d. Here c comma d both are the real numbers. Means it is the combination of the rational as the irrational. In the introduction part, I told you that this x should be the power of the whole number, but it should not be the real number or any negative exponent. It should not be there. So this is the 0 of this polynomial, and this was about the exercise 2.2. Please keep watching my videos. And 2.3 and 2.4 will be solved in the next video. Thank you.